Hey, hello there. So tonight I'm gonna quickly code the question 273 integer to English words. It's not a hard level question, but it's more on the carefulness in the attention to the details instead of the data structure knowledge or algorithmic syncing kind of the difficulty is in the organize the code, make it clean and not messy and not making mistakes. It's not hard in the coming up with a solution. It's just the execution of writing the code with certain level of complexity. So the question is asking us to convert a non-negative integer into its English words representation. So it's pretty much like writing a checks. I still write checks for my rent and the utility. The utility gets changed every month, so the number is changing. I guess I'm exercising actually performing this in real life. So the number we have is non-negative, so it's not going to be anything that's so it's even more resemblance of check writings. You're not going to write negative numbers in checks, right? So it's 0 towards 2 to the 31 minus 1. So how big is this number? So that tells us the upper bounds is telling us how many consecutive chunks of 3 that we need to deal with. So just gonna misuse Leetcode's system for doing some calculation. I'm just gonna pass this as a test case in there. So with this, we have now awesome input examples. So just disregard all those 1, 2, 3, 4 there because they are not as good as this one we have. So the number is 2,147,483,647. So it's in the chunks of 3 and with its own English words indicating which chunk it is from, and within the chunk it is as if the number is just a number within 1,000. So the function, if it can deal with numbers that's under 1,000, we just continuously we're just gonna call the function for the three digits and get that word representation and plug in the either a billion, a million, 1,000 to that word, and just disregard those 3 digits and move into the left or to the right part, and that's pretty much how we in the kind of a divide and conquer part to fashion to reuse the code. And under 1,000 there is a few cases. Let's look at that. So under 1,000, there the first kind of case that's under 20, because every number under 20 has its own word, and there is not any kind of reusable patterns for that group of numbers. So it's just going to be a direct mapping between the integer to its English words representation. And the other case is above 20 and under 100. In that case, the tens have its own words, like 10, 30, 40, 50, and after that is after that word, tens word, we reduce the question into the under 20 case. So it's the tens plus the case 1. The third case is in the hundreds, so it's the digits plus 100, and then reduce the question into the tens, into the second case. So there will be code reuse here as well for the case that's under 1,000. So you see the divide and conquer that's being used in two kind of fashions. One is for consecutive chunks. We treat them as if it's the number that's under 1,000. Just plug in the, just append the millions, billions in there. And if it's within 1,000, that will be code reuse as well for 3 different cases. So let's quickly code this. It's kind of tedious, so I will, but the code is quite obvious. So I'm gonna not talk too much, but concentrate on coding. So this is going to be the main workforce function that takes in the integer word and surround the English words representation. And we're just going to kind of recursively call this function to reuse the code that can process stuff. So if it's under 20, we just call this. It could be a hash map, but it could also be a character array. The benefits of it being a character array is that you know, we just have 0 to be an empty string, 1 to be 1, 2 to be 2, 3 to be 3. We basically use the index as the key to access the string values, and for some languages it can be much faster than the hash maps. We can also use a hash map for integer number as key and the English words, but the memory may not be consecutive, so I guess the can be slightly slower. But I don't think it's going to be much slower, but there might be slight benefits with character array. I'm just gonna code two numbers in here, and you get the idea, so that I can fill it up later on. So if it's tens, it's if it's under 100, it's the we grab the digits and look up at the tens representation words for that. It's a tens, 20s, and then we just recursively call the 2 words to process the under 10 part. So obviously we'll have another either a hash mapping or character array for this. In this case, I'm only grabbing the if it's 10, it will become 1. If it's 20, it will become 20. So here I'm also using index to access those words. And I actually don't need to fill meaningful stuff in the first 2 locations, because under 20 cases will always be handled by this mapping here. You get the idea. I will fill in the value later on. So it's similar to the tens case. We grab the digits and just gonna use that digits, pass that digits from the from the under 20 mapping, and append a 100 word. The remainder part is reduced to the case 2, so we can just call the 2 words function on it again. So with this, we should have the code that deals number that's under 1,000, and then what left with us is breaking this integer number into a section of 3s, and just recursively call the 2 words to get the English words representation for the 3 digits, 3 consecutive digits. and plug in the billions, millions, and thousand. For this, we're gonna enumerate with the over the chunks. Is that how we chunks? My brain today. So what we have here. So in the very first iteration, the power is 1, and the number will be compared with 1,000 to the power of 2. So we are looking at stuff that's under the million part. Actually, strictly under the million part. So it's we are dealing with something in the thousandth part, and we can just do a mod, do a div mod by 10 to the 10 to the 3, 10 to the power, 10 to the power actually, 1,000 to the power, and the quotient part is going to be passed through the 2 words plus a word for the 1,000, and the remainder part are going to be passed through the 2 words function as well. It's quite similar to this 100 case, except that we are using 1,000. And instead of looking at the single digit from the mapping, we're going to use the 2 words function, because the quotient is the consecutive three digits that in the thousands territory in the first iteration. In the second iteration, it's going to be looking for the case that's as if the number is in the millions territory. In the very last chunk, it will be the billions. So the chunks itself, it's an array of 3 things. It's just gonna copy and paste thousands, million, and billion. And obviously, if we have number that's larger than 2 to the 31 minus 1, we can potentially go into the trillions territory. The only code change that we need to do is to just add another trillion here. So the looping can handle that addition better. So if you have if and else statements dealing with this case, then it will become a little bit messy and a little bit difficult to expand to trillions. Yeah, so yeah, if you are the U.S. government, you're not writing trillions check for the people. So it's the number to the power and the number divided by mod by the 1,000 to the power. Oh, sorry, it's a function now. Sorry. So that's pretty much the I'm basically appending list of stuff. In the end, I just use a string builder to concatenate everything, so that I'll try to avoid doing string building whenever I have a new word. So I just want to do that one last just want to do that one time. So I'm just gonna copy this. That's in the right location. So in the end, I should just return the string that for all those words concatenating together. And if it returned me nothing, I should return the empty string. I should return 0. That is if the only thing that I loaded that I returned is the under 20 with index 0, which will be the thing that I return will be a list of empty string So when I join them all together, it will be a empty space. So an empty space, yeah, not an empty space, just an empty string. If it's an empty string, that will be evaluated to as false. So I will, you know, actually return 0 instead of that. So that's pretty much the code. All I'm left is to practice some English spelling. Some more spelling. $70, $80, $90. Yes. Do I have a somehow I used to think 90 as NINTY without E. I'm still not sure. maybe from the when I see error I should know better. So let's look at the code. So we got these mappings. They are character arrays, and we're just going to look up the value by the index. So if it's 20, we're going to use the 2 to access the 20 here. If it's 50, because we're going to use an index 5 to access this integer, this word 0, 1, 2, 3, 4, 5. So if it's under 20, we're going to use the number itself to access this array to grab the value. If the chunks are sorted in from smallest to biggest, thousand, millions, billions, so that when we call this method, if it's in the millions, in the thousands part, this is not going to be triggered. So it will try to deal with the shatter the million part first, and reduce the number into the thousands territory, so that in the recursive call it will actually trigger the execution here in the first iteration in the for loop. So we get something million, something thousand, and something. So that's how we use this for loop to deal with that. And this can expand to deal with trillions. All we need to do is just add a trillion into these chunks here. So it looks okay. Yeah, let me run through the example. No. Maximum recursion depths exceeded in comparison. So why is that? So let me try a smaller number. Yeah, the hard level kicks in. What's the problem I have here? No? It's always none. function object, it's not subscriptable. Pretty bad shape today. Any other occurrence of this? What about the biggest number case? Will this work? Also throwing a 1,000 case, a 0 case in there. Okay, so I think I got rid of the arrows. Let's submit it. Not working. 20. Okay. Why is there an extra space? Can I just strip it? If it's exactly 20. Oh, I have one empty space here, so that when I'm joining it's 20 plus that. So, So if it's the empty string here is really giving me a pain. You know what? I'm gonna add one line here. So just add this one case for this, so the string builder thing, it wouldn't add extra space in there. So I don't think I need a strip in there anymore. Let me add one more case in here. 20, maybe deal with hundreds as well. Let's say 300. Okay, looks good now. Finally, yeah. So that's the question for today. It's in terms of data structure and algorithm, it's really not difficult. Yeah, pay attention to details and try to look for bugs before you say you're done, I guess. Alright, so that's the question.